Yeah, so today we will do review for midterm, the first session. We will do 2 sessions. Today the first one, Wednesday the second one. Yeah. So after Wednesday's class, then that's the starting time for our midterm exam. Yeah. All right. First, let me give you that specific time again. So what's the real starting point for this midterm exam? Yeah. Okay. All right. Yeah. So actually we have 2 assignments. So the midterm exam, I use 2 assignments to, to split part A, part B. Yeah. So part A of the midterm, yeah. So I make it as quiz number 3. Quiz number 3, at the same time, it will be used as part A of midterm. Okay? Yeah. Same thing. Quiz number 3. Okay? All right. So you know the format. So I do not need to explain anymore. Then part B. Yeah. So that's our, computation part. Yeah. We know 15 computation questions. Okay? Yeah. PDF. Yeah. So this is, you need to download the PDF file, just like the homework assignment number 1. Yeah, so you need to, work on it. Okay, the same way you work on the homework assignment. All right. Then, in Canvas, I set the starting time in Canvas. Okay, yeah. Start right after our Wednesday's class, right after. So here, let me give you the exact time. The assignments will be 2 assignments will be available on Canvas. Okay, that time, that's the March 18th, right? Our Wednesday's class. Yeah. Our Wednesday's class officially finishes at 6:55, right? 6:45. Yeah, 6:45. Okay. Yeah. All right. So let me, choose a easy time. Yeah. So 7 p.m. How about that? 7. 15 minutes after our class time. Officially finished. Yeah. 7 p.m. Yeah. Yeah. 2 assignments. Yeah. So the starting time. Yeah. Yeah. So end time. Same. Those 2 assignments the same. Okay. Part A, part B. Same. That's March 22nd, Sunday. End of the day. Yeah, so the meaning, end of the day. Yeah. Online, okay? Yeah. Yeah. So the online, for the, open book, open notes, online tools. Yeah, so you can use, Yeah. But for the final in-person test, so our rules will be different. Okay, our rules. Although still open book, open notes, and you can use your laptops still, but I do not allow you to use search engine, AI tools, communication software in our final exam. The midterm, so no such restriction, just like a regular homework assignment. Yeah, so that part is different. Yeah. All right, yeah, so that's, I want to talk about another time, yeah, because some students still ask me about the midterm, starting time. All right, so now let's start the review. Session 1. Yeah. So for the quiz 1, I only need to explain this question. The other 9 questions, I look at the statistics. So you did quite well, above 90. Yeah. Consistently above 90. Yeah. So I do not need to explain. Yeah. But this one, 30, about 30%. Yeah. All right. So this question, I look at the answers of those students who missed this question. So the biggest problem is they based on Horner's rule. And here we need to use Pascal's triangle. Right? Yeah. So here, so let me explain the reason. Yeah. First, the answer is 3. The answer is 3. Yeah. But those students, based on the Horner's rule, answer, 6 or 5. Some students use 6, some students use 5. Yeah. So the problem, so here I want to compare. Yeah. Horner's rule here, and here we need to use the Pascal's triangle. So those students who missed this one, so they didn't realize this polynomial has a special structure for the Pascal, in this Pascal's triangle structure. Yeah. All right. The Horner's rule for the general case, we know. General case. So no specific structure we can take advantage of. The general case. Yeah. So then it's the best one. So the best solution for the general case. Yeah. But not for special case. For special case, it may not be the best solution. Yeah. Special case means special structure. Yeah. So when your polynomial have special structures, so you can take advantage of the special structures. Yeah. Here, Pascal's triangle is a special structure. Okay? Yeah. All right. So here, the binomial formula x plus 1 to the 6. Yeah. Addition, we do not count. Yeah. So we only count number of multiplication. Addition, very fast. In CPU, we know, extremely fast. Yeah. So we don't worry about addition, because addition to multiplication ratio approximately 1 to 10 ratio. Okay? So that's why we do not need to worry about the addition part. Yeah. All right. So then no addition, then only look at the multiplication. How many here? Yeah. Oh, just a minute. Yeah, 3, right. Yeah. Right. Yeah. 3, right? Yeah. You have different ways to get 3. Yeah. Yeah. So one way, yeah, because square, because you need one multiplication to get a square. Yeah. Then, cube of that square. Another is, you need 2 multiplication to get a cube, then you do a square. Another multiplication for that 3. Yeah. Yeah. So, Yeah, so that's for the, those students who are not familiar with the Pascal's triangle. Yeah. All right. Yeah, so that's the quiz 1. Quiz 2, I look at the statistics. So I noticed 3 of the questions. Yeah. 3 of the questions I need to explain. Yeah. Especially the last 2. Yeah. Last 2 questions, number 9, number 10. Yeah. The missing rate, pretty high. The number 10 has the highest missing rate. Yeah. All right. Question number 5. Yeah. So the missing rate not very high. Yeah. But the 20-30%. Yeah. That level. Yeah. All right. Correct answer 42. Yeah. So some students give me 45. Some students give me other different numbers. Yeah. So here, let me explain. Yeah. So solving this question, there is a special thinking, special way. This special problem solving thinking way is very useful for questions like this, because here there is a special condition here. Yeah. So later you will see in many of our homework assignment test questions, we will have the questions like this one. Okay. So usually I add one or two special conditions. Here there is one special conditions. All right. So one way to solve the questions of this type. Yeah. So we do the thinking in this way. Yeah. First, we ignore the given condition. The first round, okay? Yeah. The first round. So we ignore the given condition. And solve it. So solve it without the given condition. Okay? Yeah? So easier. So this version, this version is much easier, right? Easier. Yeah. This version, much easier. Yeah? Then, remember, in our problem solving, we have a strategy. We can modify the given problem with some easier version, right? Yeah? This is the way we modify our given problem. We just remove the given condition. That's the modification. Okay? Yeah. Then we just solve an easier version of the original problem. Yeah. All right. So after we get a solution, add that condition back. Add the condition back. All right? Yeah. But you need to do some more work. After you add it back, you need to make some adjustment. Okay? Yeah? So you need to modify your previous solution based on the given condition. Yeah. So previous solution. Yeah, so this strategy, very common, okay? Yeah. All right, yeah? So for this coming midterm exam, homework assignment number 2, and the final exam, so you will see large number of questions. in this format, this setting. Yeah. All right, here, let me show you. If you ignore this condition, then very easy. Yeah. So those students who gave me 45 as the answer, then let's ignore the given condition. Okay? Yeah. Because our n equals 10. Then we have the formula for the maximum number of inversions with n elements, right? Yeah. So the max number of inversions. Yeah. So we have that formula. 1/2 times n minus 1. Yeah. So this time n equals 10. Yeah. So 1/2 times 10 times 9 equals 45. Yeah. All right. Then, this is the step 1. Okay. Yeah. Step 1. Step 2, the modification part. Yeah. So those students forgot to this second half. Yeah. So they didn't modify from 55 to 52. So how to see that 52? Yeah, look at the condition. The first 3 elements in ascending order. Okay? Yeah. So this condition, after we add this condition, we can see among these 3 elements, no inversion, right? So, because in ascending order, no inversions in these, within these 3 element subset. So it's in the whole set, it's a subset of that whole set, no inversion. Okay, all right. Now, that means when we count the total number of inversions, we include these 3 elements subset, right? Yeah. When we do the maximum number of inversion counting, we include these 3 elements. Yeah. So that means the inversions caused by these 3 elements was counted in our first round, right? Yeah. So how many inversions? How the maximum number of inversions in 3 elements? We need that number, okay? Yeah, so here, max number of inversions in this 3-element subset, right? Subset. That number is 3, right? 3 inversions. Maximum number is 3 subset. Yeah. So that number, this 3 number, was counted before in the first round, but we should not count these 3. That's why we need to remove it from our first round solution. First round, the solution to the simplified version of the problem. Yeah. We did overcounting, so we need to make it right. Right? We need to fix the wrong part. Yeah. So that's why the final answer, yeah. So the final, you need to do final adjustment. Okay? Yeah. Final answer, 45 minus 3. So you get 42. Yeah. Yeah. The good thing is most students got this part, but I hope those students, so you understand the thinking way like this. Yeah. Okay. All right. Yeah. So that's, and it is a common strategy for many of our problem-solving questions. Common problem-solving strategy. Yeah. All right. Yeah. Next one. Yeah, number 9. The last 2 questions, concept questions. Yeah. So let me explain. So why so many students missed? So number 9, based on my impression, probably around 40-50%. 40-50% of you missed that question. But number 10, it's like 80-90%. Yeah, extremely high. Missed question number 10. Yeah. All right, let me explain that part. Yeah. So number 9, yeah. Is it true? Answer is no, not true. Yeah. All right. Yeah. So let's look at the details. Now, F1 in big O of G of n, we know it's upper bound, right? Yeah. So this condition tells us, so there we can find, let's say C1. Okay. All right. We can find positive constant C1 times G of n. Yeah. Yeah. Here we know all these functions, f function, g function, all of them should be positive functions. They're very positive. So we don't need to consider the sign, okay? Positive, negative sign. Yeah. So all these numbers, positive numbers. Yeah. All right. So then the second condition, this one, based on our definition of the asymptoticness, that's the lower bound part, right? Lower bound. So then, yeah. So we can find C2 times G of m less than or equal to F2 of n. Yeah. Yeah. Now, when we add these 2 functions, F1 and F2, yeah, the big theta notation tells us we should be able to find both upper bound, lower bound, right? Yeah. So the sum of these 2 functions should have both upper constant multiple of G of n as the upper bound, another constant multiple of G of n as the lower bound. That's the meaning of the conclusion part, right? Yeah, it's wrong. Yeah. So why wrong? Yeah. Counterexample. Yeah. So here, to answer many of our concept questions, you need to get a counterexample. Yeah. So, yeah. But for many students, so they feel very hard to find counterexamples. Yeah. So here, I want to show you how to find counterexamples. Why it is wrong. All right. Yeah. So here we only need to consider simple examples. Yeah. So when we make counterexamples, we don't want to make very complicated examples. Yeah. So relatively simple counterexamples. Yeah. All right. So here, let me show you. Yeah. As simple as possible. Okay. All right. Counter example. All right, yeah, all right. So F1 of n, yeah, can we make equals n? How about that? Yeah, simple, right? I want to make it simple, all right? Then G of n. Another simple function, how about n squared? Simple, right? Yeah, both simple. All right, first thing, do we have the first condition? We have, right? Yeah? Yeah, upper bound. Yeah, so definitely we can find the upper bound, right? C1 equals 1, for example. C1 equals 1. So upper bound. Right? Yeah. Easy. Yeah. Then F2. All right. F2. How about we make n cubed? Also simple one, right? Also simple one. Then we also have the lower bound. We have the lower bound, right? Yeah. N cubed greater than C2 times G of n. C2 also equals 1, right? Then, but F1 plus F2 equals n plus n cubed, right? N plus n cubed, yeah. N cubed is the dominant term. So we look at the dominant term. Yeah. So n, we do not look at it. We ignore it. Yeah. Yeah. Then if you only look at F2, right? The dominant term. Then you only have the lower bound. You don't have the upper bound. How can you find any constant C multiple of G function as the upper bound for this F2? No, you cannot. Right? Counterexample. Yeah. So try to find a way based on your understanding. Yeah, because when people, so how to make a counterexample? So we use our experience. We use our understanding. Yeah. So we need to, spot on the critical parts. Critical part. Yeah. Upper bound, lower bound. Yeah. So which part? Yeah. So we need to have good understanding on the main parts of the concepts. So you can make your special arrangement in your mind to make those counterexamples. Yeah. All right. Yeah. Yeah. Next question, number 10. We need to, in order to tell which statement is correct, which statement is incorrect, we need to keep doing the counterexamples. Yeah. Making many different counterexamples. Yeah. So that's the reason why so many students, because they couldn't find appropriate counterexamples. That's probably the main reason. 80%, 90% missed that last question. They couldn't find counterexamples. Yeah. So I'll show you how to find counterexamples based on your solid understanding. Why people feel that special skill part so hard? Yeah, because you need to have very solid understanding on the related concepts. Yeah, let me show you in question number 10. Yeah. Because 4 options I need to, in order to disprove 3 of the 4 statements, I need to find 3 counterexamples. Yeah. For the correct one, but I need to, because you couldn't find a counterexample, right? For the correct statement, nobody can find a counterexample. Yeah. But we cannot say, if we cannot find counterexample, then it's correct. We cannot say that, right? Yeah. So we need to use the positive way to comprehend. Yeah. So why that statement is correct. Yeah, all right. So let me show you the last question of quiz number 2. Yeah. So this one. Which of the following statements about asymptotic notations is correct? The answer is C. Okay, yeah. So most students who missed this question gave me B option. Yeah. Small number give me D option. So then only one student gave me A option. Yeah. Yeah, but so let's look at why. Other than C, all the other options are incorrect. Yeah. All right. Yeah. So let's look at the B first. Yeah. not counterexample. So, yeah. So you can see, yeah. Right. Also, so we need to find counterexamples. All right. Yeah. That part is relatively hard. Yeah. For you, for most of you, it's hard. All right. All right. So the B counterexample. All right. Based on the solid understanding. Okay. All right. So the condition tells us. This condition tells us the limit f of n over g of n. Infinity, right? Yeah. Little omega means infinity. Little o means 0. Yeah. So these two cases. Infinity. Okay, all right? All right. Then, so we want to find counterexample that satisfies the first condition, but it does not satisfy the second condition. Okay? Second condition, that means the limit root of f of m over g of m not infinity, right? Yeah, not infinity. Okay, yeah, yeah, it could be less than some constant c. Then it's not infinity, right? Yeah, or 0. Okay, yeah, yeah. So if the limit is 0. Yeah, because this c could be, non-zero constant or 0. Okay? Yeah. Yeah, I try to separate from O. Yeah, it's a number 0. Okay? Yeah. Yeah, some people wrote, try to distinguish with O, put a, cross. Yeah. All right. Yeah. So let's do this way. Okay. All right. How about make this here f of n equals n cubed, and the g of n make it n squared. How about that? Okay. Then f of n over g of n infinity, right? Yeah, because n. But when you take square root, when you take root of f of m, you get n to the 3/2. 1.5. 1.5 less than 2, right? Yeah. So then you take limit, it is 0. So it's not in big omega. So it's in little omega, right? Yeah. Counterexample. Yeah. Yeah. So that's for B. Yeah. All right. So the second one, D. Yeah. So several, 2 or 3. Yeah. Students. Yeah. D. Yeah. F of a in a big omega. Yeah. That's the lower bound, right? Yeah. Big omega, lower bound. It implies that F of a in big theta, big lower bound and the upper bound, right? Yeah. So here we do not even need to find a counterexample, right? Yeah. Although you can find a counterexample. So if you want, okay, you can find a counterexample. Yeah. So yeah, because here we try to practice ourselves how to find counterexamples, right? Yeah. So f of n equals n cubed. Yeah. G of n equals n squared, right? Yeah. Yeah. Easy. Yeah. Then you have the lower bound, right? Yeah. Yeah. Very easy to have lower. But you do not have the upper bound. Okay? Yeah. So we have the lower bound. We have at least one, because it could be many lower bound, right? A lower bound. But no upper bound. Oh. Yeah. No upper bound. Yeah. Simple counterexample, right? The last one, option A. Little o, yeah? So we know the limit of that ratio equals 0 implies square. Yeah? Square still ratio. Yeah? That's easy, right? Yeah. So similar. Yeah. Also counterexample. Yeah. Limit. All right. Yeah. So this time you need to control the order of growth function. Okay, order of growth, control. Okay, yeah, because the square, when we take square, we double the order of growth, right? Yeah. So you can, all right. So f of n, yeah. How about this? F of n equals n. Okay. Order of growth is 1. Okay? Order of growth is 1. All right. Yeah. Then, g of n, it should have higher order of growth than f. Okay? Yeah? So then we have this little o thing. Okay? So how higher cannot be too much higher. Too much higher than when we double, so when we square f function, it cannot be greater than that of the g function. So we should control slightly higher. Yeah. So n to the 3/2. 3/2. Only 1/2 higher. All right? Not too much higher. So we control it. Yeah. Then f squared order of growth becomes 2. Yeah. But g of n order of growth still 3/2. So 2 is greater than the 3/2. So it cannot be in little o, right? Little o notation. Yeah? Yeah. Grows faster, cannot be in the little o notation. Yeah. So here, using these 3 counterexamples, not very complicated. Yeah. So we try to make them as simple as possible. But you can feel about it. Yeah. In order to get a successful counterexample, so you need to have very good understanding of the concepts. You need to be able to grasp the main properties of the concepts. Upper bound, lower bound, order of growth, and how to control order of growth. So those things you need to understand very well. Then you can make good, appropriate counterexamples. Yeah. All right? So not that easy, not the random way. Okay? Yeah, you cannot make good counterexample in some random play, right? Random manipulations. Yeah. Nobody. Yeah. It's rare. I would say it's rare. Yeah. No. All right. Yeah. So any question? Yeah. So you can ask me. Yeah. All right. So we complete the selected questions for the first 2 quizzes. Yeah. All the others, when I look at the statistics, all above 90%. Yeah. So I feel so you should be okay. Yeah. Higher than 90%. All right. Then, homework assignment number 1, concept part, the first 10 questions. That's our part A. Yeah. This one, I need to explain many of the questions. Yeah. Specifically, 8 of the 10 questions. Yeah. Yeah. The first 2 are relatively easier. First two, I do not need to explain. Yeah, yeah. Pretty. Although small number of students missed a little bit, yeah, but not hard to understand. So I skipped the first two. So I will explain the remaining 8 questions. Yeah. All right, one by one. Yeah. Yeah. All right. Question number 3. Yeah. Find the minimum of. Actually, this one you didn't miss much. You didn't miss much. Yeah. Actually, the correction rate is very high. Yeah, I think above 90%. Yeah, yeah. So the answer, algorithm uses then answer no. Yeah, answer no. Nobody can do it because actually we know the answer, right? We know the optimal algorithm we can do by this many comparisons. And we know this one, when n is sufficiently large, it should be greater than this expression, right? Yeah. When n is sufficiently large. Yeah. Yeah. So we can estimate it. Yeah. After that n0, yeah, we can find that n0, but we don't need to do it, right? Yeah. So if you can envision, yeah, so here, so you need to, based on your understanding, so you need to, make some envision. Yeah. Oh, yeah, I can see it. Yeah. Yeah. So that's okay because I do not ask you, give me n0 such that when n is greater than n0, then this n minus 1 is greater than this ceiling function. Yep. I do not ask you to do that. Yeah. You just see that trend. Okay. See that trend. So it's good enough. Yeah. All right, so that's this question. Next one. Yeah, this one. Yeah, actually this one, the missing rate is very high. Okay, yeah, yeah. But so here A, B. The correct answer is B, not A. Yeah, but most of you give me A. So here, let me tell you why. So where is the point? Main point. The problem occurs. Yeah, there is a special case. Special case that calls the problem not true. Okay, make it not true. That special case n equals 6. If n is greater than 6, it's true. But only some problems, yeah, the statement is false when n equals 6. Why? Yeah, n greater than 5, so 6 is included in the range. So we need to consider 6. Yeah. So why that statement is not true? Look at such that only 5, right? That only tells us you can only have 5 of the n elements that are in place, but not more than 5, right? If more than 5, then the conclusion statement is incorrect. Only means we cannot have more than 5 elements in place. But think about when you have 6 elements. If you make 5 of the 6 elements in place, the last one is forced to be in place, right? The last one is forced to be in place because you have no other places to go. Then suddenly you have suddenly you have 6 elements in place. So that's different from this conclusion statement, only 5. So that's the only problem. And another thing, because when we talk about if the given statement is true or false, true means 100% true. You cannot have 99% true. not allowed. Must be 100% true. So even if you have one special case not true, we cannot say the whole statement is true. So the whole statement we treat it's a false statement. Yeah. But for those students who give me option A, I give partial credit. So I took 2 points off. Yeah. Yeah. So partially correct, but not completely correct. Yeah. So partial credit. Okay. Yeah. All right. So that's this question. Yeah. So this one, yeah, another big missing rate question. Correct answer is B, but at least 50% of you pick option A. You need to do calculation a little bit. Yeah. You know, some students, yeah, because the calculation is not that trivial. So you need to be very familiar with the basic algebraic operation rules, properties. Yeah. But, you know, that part, at least for some of the students, relatively weak. They cannot master that part. Yeah. So here I show you how to do the calculation. The calculation is non-trivial. Okay? Non-trivial. Yeah, because so many levels, you know, quite confusing. Yeah. Very confusing. So now let me calculate. First one, second one, then we do comparison. We can see clearly which one is much larger. Yeah. So that's this question. Let's calculate the first one. First one, much easier. Second one, a little harder. The first one, you know, log base 10, yeah, yeah, easier. All right. For the first one, before we do the calculation, let us write n as a base 10 number, because here it's a base 100 number. So we need to change from base 100 to base 10, the first step. Base 100, we need to do the conversion to the base 10 representation. Yeah. Do this work. All right? Yeah. So 100 equals, first the base equals 10 square, right? Then certain number. Yeah. Then we use the property. Yeah. So one algebraic property about the, you know, exponential operation. Yeah. n equals m times n. Okay. Product of the, you know, two exponent numbers of two levels. Yeah. All right. So here, the product 10 to the 2 times, yeah, 2 times 100 to 100. Okay. All right. All right. Yeah. Now we can calculate that for option A, log base 10 of n. Yeah. Same base, log base, exponential function base, same base. So we only take the exponent number 2 times 100 to the 100. Okay? Yeah. But 100 base still relatively hard to see, right? Yeah. So we like to convert it to base 10 numbers. All right. So let's do another round conversion. 2 times 10 squared to the 100. Another round conversion. So then we apply this property another time. So you have 2 times 10 to the 200. This number, okay? Yeah. So that's good enough, okay? Yeah. When we do comparison, yeah, So this we treat as a standard representation, base 10 representation. Very easy to do the comparison. All right, then for the option B, we also want to write it as a base 10 representation. So then very easy to do the comparison. Yeah, so let's do that calculation. All right. So this time, so it looks pretty complicated, but we should be very, So here I just write a hand, so then I just use our new representation to do it, right? Negative 100. All right. So new representation this time, 10 to the 2 times raised to this number, negative 100. Right? Yeah. Then we apply this property again. All right. 10 to the product of m and n, right? Product of m. But the product, when we do the product, we need to use the base 10. All right? So that's base 10 of 200, right? Then times base 10, 100. 200 minus 100, it's 100, right? Yeah. So after simplification, 2 times base 10 is to 100. Now you compare these two numbers. All right? Yeah. Because this number, if we replace 2 by 10, it will be larger, right? 10. So then it's less than 10 to the 201. The exponent under the 201, but exponent under 2 times 10 to the 1, much bigger, right? Yeah. We'll compare the exponent number. A, that's just the 201, very small. And a B, the exponent number, 2 times, actually, because it's both 2, So I would, do not need to do that, right? Oh, sorry, sorry, I mean, still 10 to the 201, sorry. So 201 versus 2 times 10 to the 100. How big is the difference, right? So big. So then you have no question which one is larger. Huge difference. Huge difference. Think about that. Although the calculation, so I said, non-trivial, but you can see we keep using this property again and again. All right? Algebraic properties. Basic algebraic properties. All right? So, let me keep going, because I have a few more questions. This one, some questions easy. This one, because we have the, a to the, right? So n to the d belongs to little o of a to n for, So this one, most of you, almost nobody missed this one. So I do not need to explain. Save my time. All right. The next one, we know this is the answer, but this one, many students, not too many, but quite some students select, other different options. All right, and this one, we know we use this log function belongs to the little of n to the d for d is positive. So we use that result. D, 0 point, many zero, it doesn't matter. Still, for the long run, in the long run, you can overcome that log function. All right, so I try to save time, so I do not. For the easy questions, I can go faster. This one, correct answer is C. But several students give me B option, and one student give me D option. So for B and D, very close to the correct answer, but not the same. So I give both cases partial credit, -2 points. Partial credit, So A, no points, no partial credit. But the difference is too big. All right. So how to get a 7? Here you need to write the P function using the similar structure of the Horner's rule way. Because you factor the common factor, right? A1, but inside A2, x to the 5th, 10 to the 15, right? So here you can see we need to do preparation. Preparation calculate x to the 4th and x to the 5th together. How many multiplications do we need? Because the basic building blocks, when we do the calculation of this polynomial, x to the 4th and x to the 5th. So first we need to address the building blocks, total number of multiplications we need. We need 2 multiplications for x to the 4th. Repeated squaring. One more, because you just multiply another x, one more. So the total 3 multiplications. All right? So preparation step, 3 multiplications. All right. After that, then you just use keep using the known numbers. All right. So here, x to the 5th. So you can use another notation, y, to represent it if you want to see it clearly. So then this polynomial we can write a1 plus a2y plus a3 y squared plus a4 y cubed. Then this part you apply Horner's rule. Because this is a general polynomial, right? You can apply Horner's rule. Horner's rule, degree 3, that means 3 multiplications, right? 3 multiplications. But don't forget, I think some students, the reason they miss that last multiplication, they give me 3. So 3 here plus 3 there, but they may forget. They may forget this last multiplication. So that's why your final answer is 7. So that's this question number 8. All right, be careful. So when you work, do your calculation work on your scratch paper in a neat way. So not in a messy environment. Sometimes, so we may, do the calculation in a messy way. So you miss here, there, several places. Yeah. All right. So that's number 8. Last 2 questions. Yeah. This one, yes. Yeah. So, most students did quite well. Yeah. So this one, answer is no. Yeah. Some students, wrote some work on paper, so I can see, the way to get an answer is correct. Yeah. Because n equals 16, right? So we apply we know this is the formula, okay? Yeah. So this is, and this formula optimal, right? Yeah, we know this is optimal. Yeah. So when you calculate, so 16, you plug in, you get 22. Yeah. So 22 comparisons, that's optimal, right? Nobody can do fewer than 22. Yeah. So here, 21. Yeah. That's simple logic. Yeah. Yeah. So this one, not very hard. Yeah. Yeah. All right. And the last one. Yeah. Last one, quite some students missed this one. Answer is E option. Okay. Yeah. E option, but some students give me C option, some students give me A option. Yeah. Incorrect. Okay? Yeah. All right. Here, you need to draw a diagram. So in this situation, because we need to have a visual understanding. Yeah, visual understanding. Yeah. To see. Yeah. So in this situation, yeah, because sometimes if you do not use the visual way, then the information, so it is not easy to see to cover the overall information. Okay? Yeah, because you write a condition here and there, but you need to view them together. So view all the pieces together. So that part. Yeah. So you may miss one piece here, another piece there. You couldn't see the whole picture. Yeah. Here we want to use a diagram to cover all the information so we can catch everything given in the question. Now, here I show you how to see. Yeah, so use a simple diagram to see it. All right. 5-element array. Yeah. So known conditions, 2 known conditions. Yeah. Yeah. So we need to do some visual representation on these 2 inequalities. Yeah. 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 Because think about, so our human understanding. Yeah. Do you have the experience? People say, one image is worth 1,000 words, right? Yeah. Have you heard of that saying? Yeah. One image is worth 1,000 words. Why is that? Yeah. Because you can have visual understanding on that. So image given quickly. When you see it, you can get a lot of information. It's worth 1,000 words. Here, we use the same phenomenon in our understanding. Image, so we use diagram to replace that image. Yeah. So worth a lot of information. If we use our symbols, we need to write a lot of things. But still, how to catch the main points? Yeah. Here, we use the simple diagram. Yeah. Try to give us overall understanding quickly. Yeah. The first inequality, so I like to draw a diagram like this. This vertical bar, 3 dots represent the 3 ordered elements. The highest one, x1. next one, x3, the bottom one, x5. All right? So the first inequality, you see clearly, okay, the relationship easily. The second one, x less than x2, so you draw another branch, okay? Yeah. Just like a tree, simple tree, branch. x2, here, the position. Yeah, because you can see the higher the position of an element, the larger the value, right? Yeah. But one thing, yeah, do not make too much assumption. Yeah, because some students, because here we do not know the relationship between x2 and x1. Yeah, you cannot see which one is larger between x1 and x2. Yeah. But some students assume one is larger than the other. Then the answer is wrong. Yeah. Do not make that assumption. Yeah. So you don't know which one is larger. All right. Yeah. The third, all right. So yeah. Now you can see the third largest for a 5-element array, right? So you draw a line with 5 dots. This is the third largest. Third largest. Yeah. All right. But the x5, you can see, lower than at least 3 of the elements, right? So it cannot be in the third largest, because you already know at least 3 of the 5 elements are greater than x5. So the best x5 can get is 4th element, 4th or 5th. So x5 can be eliminated quickly. Yeah. From this diagram, you can see it quickly. Yeah. But if you just look at the symbols on paper, yeah, it's not that easy to see it, right? Yeah. Because you need to use your abstract logical reasoning to see it. You still can see it, but in an abstract way, right? Here, diagram, it's a concrete way, right? You see it in a concrete way, yeah? Because one image worth 1,000 of words, yeah. Yeah? So that human behavior, right? Yeah. Yeah. So we need to use that. Yeah. So in your problems, yeah, so I will finish. So then, in our problem-solving questions, test questions, future homework questions, many questions if the relationship relatively complicated, yeah, because I may give you, many inequalities like that. Yeah. So you need to draw. Oh, so here, what do? We organize data. You treat this step. We organize our data in a form that we can understand easily. The purpose, we want to understand our data well, yeah, so we use this visual way to organize the data, so we can see all the properties of our data clearly. That's the purpose. Okay. All right, so that's it. On Wednesday's class, I will focus on part B, because at that time I will finish the grading of your part B, so I can talk about the specific problems in that part B. Yeah. Computation questions. Yeah. All right. Yeah. See you Wednesday. Yeah.